Understanding hypothesis testing. A hypothesis is a statement or a tentative theory that aims to explain facts about the real world. It is an educated guess based on observations, which the researcher seeks to test through statistical analysis. Hypothesis testing is the process of using sample data to make inferences or generalizations about a larger population. It helps to determine whether a statement or assumption about a population parameter is likely to be true, or if the observed results are just a coincidence. Why hypothesis testing is important. Hypothesis testing arises from practical problems that require answers. Researchers form hypotheses, educated guesses, about the problem, which are then tested using statistical techniques. It allows researchers to make evidence-based decisions by examining whether the data supports or contradicts the hypothesis. However, one must remember that the truth or falsity of a statistical hypothesis is never known with certainty unless the entire population is examined. Types of hypotheses. In hypothesis testing, there are two main types of hypotheses. 1. Null hypothesis. This is the default hypothesis and typically suggests no significant effect or relationship. It is always expressed in the negative form and contains an equality sign, e.g., no difference, no effect. It serves as the working hypothesis and is tested to determine whether there is enough evidence to reject it. 2. Alternative hypothesis, H1. This is the hypothesis the researcher expects to be true, and it represents the outcome the researcher seeks to prove. It never contains the equality sign and uses inequality signs, e.g., or is not equal to. The alternative hypothesis is accepted when there is enough evidence to reject the null hypothesis. Understanding rejection and non-rejection. When performing hypothesis testing, if the null hypothesis, is rejected, it means that the data provides sufficient evidence to declare it false. On the other hand, if the null hypothesis is not rejected, it does not necessarily mean that the null hypothesis is true. It simply means that there is not enough evidence to prove it false. Level of significance. The level of significance, alpha, defines the probability of rejecting the null hypothesis when it is actually true. Common significance levels are 0.05, 5%, or 0.01, 1%, which indicates how confident you can be in your decision. For example, a 5% level of significance means there is a 5% chance that you would mistakenly reject the null hypothesis when it should be accepted. In other words, a 95% confidence level is maintained in your decision-making process. One-tailed versus two-tailed tests. 1. One-tailed test. When the rejection region, or the area where we expect a significant effect, is located at only one extreme, either left or right, of the range of values for the test statistic. One-tailed tests are used when the hypothesis is testing for improvement or reduction in specific aspects, e.g., improvement in test scores or reduction in errors. 2. Two-tailed test. When the rejection region is located at both extremes, both sides, of the distribution. This is used when you are testing for a significant difference between two samples, regardless of the direction of the difference, e.g., testing if two groups have different means. Steps in hypothesis testing. The hypothesis testing process follows a 5-step approach. 1. State the hypotheses. Formulate the null and alternative hypotheses. 2. Choose the significance level. Set the desired level of significance, e.g., 0.05 or 0.01. 3. Select the appropriate test. Depending on the data and sample size, choose a statistical test, e.g., z-test, t-test, f-test. 4. Perform the test and calculate the test statistic. Calculate the test statistic based on your sample data. 5. Make a decision. Compare the p-value to the significance level and decide whether to reject or fail to reject the null hypothesis. Normality tests and other assumption. Before performing hypothesis testing, you need to ensure that your data meets the necessary assumptions, including normality. Normality tests such as the Shapiro-Wilk test, for smaller sample sizes, and the Kolmogorov-Smirnov test, for larger sample sizes, check if the data is normally distributed. If your data is not normally distributed, you may need to apply other statistical techniques or transform your data. Other tests like skewness, measuring asymmetry, and kurtosis, measuring peakness, are also important to assess whether the data aligns with a normal distribution. Testing the significance of differences. Different statistical tests can be used to test the significance of differences. 1. Z-test. Used when the population standard deviation is known and the sample size is large, n greater than or equal to 30. 2. T-test. Used when the population standard deviation is unknown and the sample size is small, n less than or equal to 30. 3. F-test. Used for comparing the means of more than two groups, e.g., when comparing 3 or more samples. Types of Z-tests. The Z-test can be used to test different types of hypotheses, including 1. Testing a population mean, comparing the sample mean to the population mean. 2. Comparing two sample means, when you have two independent samples and want to compare their means. 3. Comparing two sample means when the population standard deviation is known. Conclusion. Hypothesis testing is a powerful tool for making evidence-based decisions in research. It involves formulating hypotheses, conducting statistical tests, and interpreting the results to make conclusions about a population based on sample data. Understanding the basics of hypothesis testing, such as the types of hypotheses, significance levels, and different tests, helps researchers in fields like educational management make informed decisions based on data, ultimately improving practices and outcomes.